Hello student, as we discussed in the previous lecture on discovery of subatomic particle that the concept of atom began with ancient thinker who proposed matter is made up of extremely small, tiny, indivisible particle called atom. Moreover, as scientific experiment advanced, our understanding about atom changed dramatically. Different scientists propose different model to explain the structure of atom, and each model help us to understand atomic behavior more accurately. In today's lecture, we will explore the evolution of atomic model starting from the earlier idea of atom, progressing through the contribution of scientists such as John Dalton, J.J. Thomson, Rutherford, Niel Bohr, and others. We will see how the scientific experimental evidences led to the development of increasingly more accurate atomic model and ultimately led the foundation of the modern atomic theory. Dear student, let's start with the first atomic theory proposed by John Dalton in year 1808. He proposed that all matter is composed of tiny indivisible particle called atom. And according to him, atom is itself is an individual. It cannot be further divided into subatomic particles. Atoms can neither be created nor be destroyed in chemical reaction. That means simply the atoms participate in the chemical reaction without undergoing any change in numbers. According to him, all atoms of given elements are identical in mass and chemical properties, which means the atoms of hydrogens are identical among themselves, and similarly the atoms of oxygens are also identical in themselves. Atoms of different element possesses different masses and chemical property, and this difference is what makes each element unique. According to him, atoms of different elements combine in simple whole number ratio to form compound. For example, a molecule of water which is formed by 2 atoms of hydrogen and 1 atom of oxygen in the ratio of 2:1. Dalton assumed that chemical reaction simply involve the combination, separation and rearrangement of atoms. Now let us look at merit of Dalton theory. His theory successfully explained law of conservation of mass and law of definite proportion. More importantly, it provides the first scientific explanation for chemical reaction and establish atom as the fundamental building block of matter. However, with the development of science, certain limitations of Dalton atomic theory were discovered. Now we know that atom is not an individual, but it further made up of 3 subatomic particles, electron, proton and neutron. Dalton assumed that the atom of same elements are identical in all respects, but the discovery of isotope shows that atom of same element may even differ in some respect. For example, the atom of hydrogen exists in 3 isotopic form: protium, deuterium, tritium, since they are of same element but they have different masses. Similarly, the discovery of isobar shows that the atom of different element may be same in some respect. For example, the atom of argon and calcium, they are the atom of different element but still their mass are same. Although some of the Dalton assumptions were later modified, still his atomic theory was a revolutionary contribution to science. Dear student, let's start with first simplest atomic model proposed by J.J. Thomson in year 1904. This model was developed after discovery of electron and was the first attempt to explain internal structure of atom. According to this model, atom is a uniform pair of positively charged and negatively charged electrons are embedded into the sphere of positive charge in such a way that It gives most stable electrostatic arrangement. This model is also known as Plum-Pudding model. In this analogy, the positive charge sphere is compared to plum pudding or a cake, while the electrons are like plum or resin embedded throughout the pudding. Another common analogy is the watermelon model. Here, the positive charge represents the red edible part of the watermelon, while the seed representing the electrons are embedded into it. The atom contains both positive and negative charge. Since the total positive and negative charges are equal, the atom as a whole is electrically neutral. Let us look at the merit of this model. This model successfully explains electrical neutrality of atom. Thomson atomic model remains an important milestone in the history of atomic structure because it was the first model to include the electron and demonstrate that atoms are not indivisible as Dalton had originally proposed. And as far as limitations are concerned, it couldn't explain Rutherford gold foil scattering experiment, presence of nucleus, and couldn't explain stability of atom. Dear student, let me to explain Rutherford scattering experiment, which is one of the most important experiment in the history of atomic structure. This experiment was performed by Rutherford in year 1911 to investigate the internal structure of atom. Let us understand the experimental set. A source of radioactive substance such as radium was placed inside the lead block. The lead block had a narrow slit which allowed only a thin, well-focused beam of high energy alpha particles to emerge. This narrow beam was directed toward an extremely thin gold foil 100 nanometer thick. Gold was chosen because it is highly malleable and can be beaten into very thin sheet containing only few layers of atoms. A circular screen coated with zinc sulfide was placed around the gold foil, and whenever an alpha particle struck on this zinc sulfide screen, it produces a tiny flash of light called a scintillation. These flashes were observed using movable microscope, which could be rotated around the screen to detect alpha particle scattering in different direction. Dear student, let us now examine the observation made during the experiment and the conclusion that completely changed our understanding of atomic structure. The observation were most alpha particles passed through straight line which are marked A. Some were deflected slightly and very few particles, one in about 20,000 pounds back. And the conclusion drawn on these observations were the line marked A represent alpha particles that pass straight through the gold foil without deflection. It indicates that most of the space inside the atom is empty. Second observation, that is the deflection through a small angle represented by B line, show that alpha particles that undergo small deflection because they pass near the positive center of atom and experience repulsive forces. Third observation, the conclusion drawn on the basis of third observation was which are represented by C lines. These are rare alpha particles that come very close to the dense center of the atom. These particles undergo large angle scattering and very few, one in about 20,000, bounce back in the original path, which indicates that the size of this positive charge center is very small. Dear student, on the basis of observation of gold foil scattering experiment, Rutherford proposed nuclear atomic model in year 1911. This model completely changed our understanding of the structure of the atom and replace Thomson plum pudding model. The main feature of this model are an atom has a small, dense and positively charged center, which is called nucleus, and the mass of the atom is just because of this nucleus. Since the size of this nucleus is very small, therefore, as compared to the total size of the atom, therefore, most of the space inside the atom is empty. The electron revolve around this nucleus in continuous circular path, much like planet around the sun. For this reason, Rutherford model is also known as planetary model of the atom. The electrons and the positive charge in the center are held together by electrostatic force of attraction, and since the number of positive charge present in the nucleus is equal to the number of negative charge of electron revolving around the nucleus are same, therefore atom as a whole is electrically neutral. Dear student, as far as the merits of the Rutherford models are concerned, Rutherford model was the first to introduce the concept of central nucleus and explain why most alpha particles pass through the gold foil while only a few were deflected. It established that the atom is mostly empty space with a dense positively charged nucleus at the center. Dear student, despite its success, Rutherford model had some important limitation that it couldn't explain the stability of atom. According to classical electromagnetic theory, a charged particle moving in a circular path continuously emit energy. Therefore, an electron revolving around the nucleus should gradually lose energy and come closer and closer to the nucleus and ultimately should fall into the nucleus. If this happened, atom would collapse within a few very short time. However, we know that atoms are stable. Therefore, Rutherford model couldn't explain this stability. Secondly, it couldn't explain atomic spectra, especially line spectra of hydrogen. According to Rutherford model, electron could with any amount of energy, so atom should emit a continuous spectrum. Experimentally, however, only discrete spectral lines are observed. Rutherford model did not specify any fixed arrangement or definite energy level for electron around the nucleus. It gave no information about the distribution of electron or their allowed orbits. Rutherford nuclear model was a major milestone in the history of atomic theory. It introduced the concept of small, dense nucleus and established that most of the space inside the atom is empty. These discovery completely changed our understanding of atomic structure and laid the foundation of modern atomic theory. Dear student, after discussing the limitation of Rutherford model, let us study Bohr atomic model proposed by Niel Bohr in year 1913 to overcome the shortcoming of Rutherford model, particularly the stability of atom and the line spectra of hydrogen. The main postulate of Bohr atomic models are, according to Bohr, atom is not an individual, rather it is made up of three subatomic particles, electron, proton and neutron. The proton and neutron are present in the center in the form of nucleus, whereas electron is revolving around the nucleus in certain selected circular path called orbit or energy level or energy shell. Secondly, electron remain in its orbit unless or until it does not lose or gain energy. These orbits are therefore stationary state, allowed energy state, because the electron present in this orbit remain in the orbit unless or until it does not lose or gain energy. Only those orbitals are permitted in which the angular momentum of electron is the whole number multiple of h over 2 pi. That means the angular momentum mvr is equal to nh over 2 pi, where h is Planck constant and n has any value 1, 2, 3 and so on. If n is 1, it represents K shell, and if n is 2, it represents L shell, and then M shell and N shell, so on. The energy is emitted or absorbed only when electron jump from one energy level to another. This can be illustrated by these figures, that when electron jump from lower energy level to higher energy level, it absorbs energy, whereas when the electron jump from higher energy level to lower energy level, it emits energy. Dear student, Bohr atomic model was a major breakthrough in the atomic theory. It successfully explained this stability of atom and line spectra of hydrogen atom. It also introduced revolutionary concept of quantized energy level, which become the foundation of modern quantum mechanics. It also helped in calculating the energy of electron in particular orbit of hydrogen atom. Now let's discuss these success one by one, starting with this Bohr explanation for the stability of atom. According to this model, electron revolve around the nucleus in certain selected circular path, which is called orbit, and unless or until the electron remain in its orbit, it neither absorb energy nor emit energy. In this way, Niel Bohr atomic model explains the stability of the atom. Dear student, one of the greatest achievement of Bohr atomic model was its successful explanation of the atomic spectra of hydrogen atom. The spectrum of hydrogen atom has played a very important role in the development of atomic structure. The spectrum of hydrogen atom can be obtained by passing an electric discharge through the gas taken in the discharge tube under low pressure. The emitted light is analyzed with the help of spectroscope. The spectrum consists of large number of lines appearing in different regions of wavelength. Some of these lines are present in visible region, some are present in UV region, and other are present in IR region. Dear student, according to Bohr model, electron revolve around nucleus only in fixed energy level. When an electron absorbs energy, it moves to a higher energy level called the excited state. As the electron return to the lower energy level, it emits photon whose energy is exactly equal to the difference between the two energy levels, and the energy of the emitted photon is given by this equation hv, which is the energy of photon. Here h is Planck constant, v is frequency of emitted radiation, En2 is energy of excited state, and this one is the energy of ground state. Bohr theory also led to the derivation of Rydberg equation, which accurately predict the wavelength of hydrogen spectral line. 1 over lambda is equal to r, or 1 over n1 square minus 1 over n2 square, n1 square minus 1 over n2 square, where lambda is wavelength, r is Rydberg constant, and these n1 and n2 are representing the ground state energy level and excited energy level. This equation is Rydberg equation. Wavelength calculated using this equation agree remarkably well with the experimental observed hydrogen spectrum. The spectral lines of hydrogen atom in different regions were grouped into 5 different series of lines, each being named after the name of its discoverer: Lyman series, Balmer series, Parchin series, Brackett series, Puffin series. And the origin of these line spectra can be explained with the help of Niel Bohr atomic model. When the electron present in the ground state absorb energy, it can excite it to any of the excited energy levels, that may be n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, and so on. And after excitation, when it come back to the ground state, it emit energy, which result in the spectral line called Lyman series, which appear in UV region. Similarly, after excitation, if electron come to the energy state n is equal to 2 from any of the excited state 3, 4, 5, 6, it result in a spectral series, that is a Balmer series, Same in case of Parchin series, Brackett series, Papan series. In this way, a Bohr model was quite successful to explain the spectral lines of hydrogen atom. Dear student, let's understand quantitative explanation of the line spectrum of hydrogen using Bohr atomic theory. The amount of energy absorbed or emitted when electron jump from initial orbit to the final orbit is given as del E is equal to EF minus EI. EI is the energy of initial orbit and EF is the energy of final orbit. Then these energy of the orbit can be represented in terms of Rydberg constant for hydrogen, RH for initial state and final state, and using the value of Rydberg constant for hydrogen, which is 2.18 into 10 raised to power minus 18 joule per atom, and putting these value in this equation, first equation, we are getting this one, and putting the value of Rydberg constant here, we are getting this one. And as we know that the energy of transition when the electron jump from one energy level to another energy level, it either absorb energy or emit energy, which is equal to the photon, that is hv. H is Planck constant and v is frequency of the emitted or absorbed radiation, and v is equal to del E over H. And putting the value of del E from this equation to this equation, we are finally getting this one, that is 3.29 into 10 raised to power 15 into 1 over Ni square minus 1 over Nf square hertz. And if the same thing is represented in terms of wave number, we people know that wave number is equal to v over c, mu over c. C is the velocity of light, and this equation, putting the value of v from here to here, we are finally getting this value, that is the wave number is equal to 1.09677 into 10 raised to power 7 into 1 over Ni square minus 1 over Ni Nf square meter. Let's study this equation in different cases. If the value of Nf is greater than Ni, as in case of absorption spectra, the value of del E comes out to be positive and hence energy is absorbed. But in case of emission spectra where Nf is less than Ni, the value of del E comes out to be negative and energy is released. And again, the expression is similar to that used by Rydberg, which he derived empirically using the experimental data available at that time. So we also discuss the origin of spectral line in different regions. Lyman series appear in UV region, whereas Balmer series appear in visible region, and rest 3, that is Parchin, Brackett, Puffin, appear in IR region. And this is what we already discussed, the Rydberg equation and meaning of all these terms. Dear student, let's understand how Bohr theory help in calculating energy of electron in particular orbit of hydrogen atom. For an electron to remain in the orbit, the electrostatic attraction between the electron and the nucleus, which tend to pull electron toward the nucleus, must be equal to the centrifugal force, which tend to throw the electron out of its orbit. So the centrifugal force is equal to mv square over r. It is given by mv square over r. The Coulombic force of attraction between nucleus and electron is given by this one, where z is the atomic number, E is the charge on electron, r is the radius distance between electron and the nucleus. When two forces become equal, that is Coulombic force is equal to the electrostatic force between nucleus and electron, we can calculate the value of v square, that is this one. According to Bohr model of an atom, angular momentum is integral multiple of h over 2 pi. So this is from the Bohr model, and again we calculate the value of v square, which comes out to this one. Now equating this value and this value, which is the value of v square, we are getting this equation, and finally we are getting the value of r. Since Z, that is the atomic number of the hydrogen, is 1, hence R is equal to n square s square over 4 pi square m e square. Here n representing the nth orbit, electron present in nth orbit. The total energy E of electron revolving in nth orbit is equal to sum of the kinetic energy half mv square and the potential energy minus ze square over Rn. The sum is this one, and from this equation we are getting this one, mv square is equal to this one, and substituting this value mv square in this equation we are getting this one, and substituting the value of Rn from this equation to this equation, finally we are getting this one and this one. This is the Bohr equation of energy of electron in nth orbital for hydrogen and hydrogenic ions. The hydrogenic ions means any ions having only one electron. For example, helium plus has only one electron and lithium 2 plus contain only one electron, and these are hydrogenic ions. And while using this expression, the energy of various orbit can be calculated. This is the value of energy for n is equal to 1, n is equal to 2, n is equal to 3, and so on. So the energy expression for hydrogen like ions may be written as this one. Here in case of helium plus, Z is equal to 2 and lithium 2 plus, Z is equal to 3 can be used to calculate the energy value. We can also calculate radius of each circular orbit according to Bohr model. The radius of nth orbit is this one, and this can be represented by this one, where A0 is equal to 52.9 picometer. Thus, the radius of first stationary state called the Bohr radius is 52.9 picometer. For hydrogen atom, radius of first orbit is 52.9 pm. Similarly, for second orbit, this value comes out to be this one, and third orbit it comes out to be this one. Similarly, the velocity of an electron in any orbit is given by the expression this one, and this is the general expression for the velocity of electron in different. Dear student, let's understand Bohr theory and concept of quantization. Since the principal quantum number can take any whole number value, the electron can process only specific fixed energy. It cannot have energy in between these energy levels. The energy of different energy levels can be calculated from this equation. En is equal to minus 1311.8 divided by n square kilojoule per mole, where n may be 1, 2, 3, 4. Therefore, an electron can move from one allowed energy level to another only by absorbing or emitting definite amount of energy. This energy is exchanged in the form of discrete packet called quanta or photon rather than a continuous flow. So the transition is only possible in between these lines, and when transition take place, only discrete packet of energy involved. It may be either released or may be absorbed. Bohr showed that electron can only in fixed energy level with quantized energies. Their angular momentum is also quantized, and energy is absorbed or emitted only when electron jump between these allowed energy levels. This concept of quantization successfully explains the stability of atoms and the line spectrum of hydrogen, making Bohr atomic theory a major milestone in the history of physics and chemistry. Dear student, now let us discuss limitation of Bohr model. Although Bohr model was a major breakthrough in atomic theory and successfully explained the stability of hydrogen atom and its line spectrum, it has several limitations as well. This model couldn't explain the fine structure of hydrogen spectrum. Improved spectroscopic instrument, scientists observed that Some spectral lines are actually split into two or more closely spectral lines called duplet or fine spectral lines. Bohr theory couldn't account for these fine structure. This model work only for single electron atom such as hydrogen, helium ion or lithium 2 plus. It completely failed to explain the spectra of multi-electron atom, where interaction between electrons become important. Bohr theory couldn't explain Zeeman effect, which is the splitting of spectral line when atoms are placed in magnetic. As shown in the figure, a single spectral line divides into several components under the influence of a magnetic field, a phenomenon not predicted by Bohr model. It also failed to explain Stark effect, which is the splitting of spectral line in the presence of electric. Finally, Bohr model gave no information about the shape of the molecule or the directional nature of chemical bonding. Therefore, it couldn't explain molecular geometry or information of the complex molecule. Dear student, although Bohr model was highly successful for hydrogen and introduced the revolutionary idea of quantized energy level, its limitation led to the development of modern quantum mechanics, which provide a much more accurate description of atomic structure and electron behavior. Dear student, let us move to the modern atomic theory, which is the currently accepted scientific explanation of the structure and behavior of atom. Unlike earlier atomic model, modern atomic theory is based on extensive experimental evidence and the principle of quantum mechanics. The main postulate of the modern atomic theory are: today we know that every atom is made up of smaller subatomic particles, electron, proton and neutron. Secondly, the existence of isotope. Isotopes are the atom of same element that have the same number of proton but different number of neutron. As a result, they have different atomic masses. For example, chlorine mainly exists as chlorine 35 and chlorine 37, which are isotope of the same elements. Existence of isobar, the atoms of different elements having some similar property. For example, argon and calcium both having a mass number of 40. Modern atomic theory also explains the atoms are not indestructible. Although through nuclear reaction, one element can be transformed into another. This process is known as transmutation and is the basis of many nuclear technologies. Dear student, another important aspect is mass energy equivalence proposed by Albert Einstein. According to the famous equation, E is equal to mc, a small amount of mass can be converted into a large amount of energy and vice versa, and this principle forms the foundation of nuclear fission and nuclear fusion reaction. Unlike Dalton theory, modern atomic theory recognizes the atoms do not always combine in simple whole number ratio. Many complex compounds, especially organic molecules and polymer, have non-integer or variable composition, making earlier rule applicable only in limited cases. Finally, although modern atomic theory has modified many of Dalton's ideas, one principle still remains valid. The atom is the smallest particle that participate in ordinary chemical reaction. While atom can be divided in nuclear reaction, chemical reaction involve only the rearrangement of atom without changing their nuclei. Therefore, dear student, modern atomic theory integrate the discovery of subatomic particles, isotope, isobar, nuclear reactions, and quantum mechanics. It provides a much more accurate and comprehensive understanding of atomic structure and form the foundation of modern chemistry. So, dear students, in this lecture, we learned that an atom consists of dense containing proton and neutron, whereas electrons are concerned, electrons are revolving around the nucleus in some energy levels. The development of atomic theory has been fundamental to understanding the physical and chemical property of the matter and has formed the basis of modern chemistry. Understanding atomic structure helped to explain chemical bonding, periodic property, spectroscopy, and many other important phenomena. As science continues to evolve, atomic models are refined through new experimental evidence, demonstrating the dynamic nature of science. This is all about for today's lecture. Thank you very much. In next lecture, we will study the quantum numbers and the distribution of electron in atom. Till then, thank you very much.